What I would talk to you about is enteric viral infections, concentrating mainly on two pathogens that cause most relevant disease today, that is rotavirus and norovirus. We know enteric viruses since the early 1970s. We know that there are more than 8 viruses that can cause acute diarrhea. And we know that acute diarrhea remains to be a leading cause of morbidity in children, especially under 3 years of age, and in the less developed regions of the world of mortality. Second, after pneumonia, causing over 500,000 deaths around the world. And of those pathogens that cause most of the disease, the viruses are most relevant, and of those, these 8 viruses that, or so that have been described, rotavirus was recognized quite a long time ago as the #1 pathogen, causing somewhere from 30 to 50% of the moderate to severe acute diarrhea cases around the world. Fortunately, we now have a rotavirus vaccine that has been in use around the world now since 2006. And the experience is showing wherever it's being used that it's producing a very significant reduction of rotavirus disease impact in medical consultations, hospitalizations, and in those areas where children die, deaths due to gastrointestinal infection due to rotavirus. So the increased uptake of vaccination around the world is having a very significant impact in reducing the burden of rotavirus disease. The pathogen now that is arising as the new leader is norovirus. Norovirus also was discovered in the 1970s. It's well recognized as a virus that causes outbreaks of gastroenteritis in cruise ships, in schools, in colleges, where adults and children are compromised. It can cause small or very large outbreaks, including hundreds of people. And it's mostly related to consumption of contaminated food, mainly vegetables or seafood, or actually any food, or contaminated water. Well, we know that we can decrease the risk of these viruses by improving hand washing, which is very important, by improving environmental health, by improving food safety. But we're also working on the development of a norovirus vaccine. There's still a long way to go. This is not an easy vaccine to develop. This is a virus that we cannot culture, and we cannot grow like we can grow rotavirus. We cannot yet grow norovirus. So the development of norovirus vaccine has been based on genetic bioengineering, creating viral capsids very similar, actually identical to the technology that has been used for the human papillomavirus vaccine. And these vaccine candidates now are in phase 1 to phase 2 trials, and hopefully we'll move into phase 2-3 trials in infants during 2017. So it is possible that we may have, if things go well, a norovirus vaccine maybe in 3 to 4 more years. So we just need to continue to work and wait, but hopefully we'll have a new solution for another enteric pathogen in the near future.
The intestinal microbiota is the community of microorganisms that live in mutualism with our body. The microbiota lives in several areas that are exposed to the external environment, like the mucosa of the gut, of the mouth and vagina, and in the skin. So we are composed of 10 times more cells of the microbial origin rather than mammalian origin. And this increases of 100 times the genome of our body. which is fundamental for several functions that are required for breakdown of food, for instance. And indeed, some animals that are germ-free, that means that they do not have the microbiota, they have to eat at least 30% more food in order to have the same type of energy harvest. The microbiota is fundamental also for other reasons, because it is important for instance, for the maturation of the immune system. And we know that animals that do not have the microbiota, they also have a reduced dimension of secondary organs of the lymphoid tissues, like, for instance, the Peyer's patches. The microbiota is also is a community that is created of different microorganisms that are both inflammatory and anti-inflammatory, and it's the balance of the two that creates the homeostasis of our body, in particular of the gut. The intestinal microbiota is the one that is mostly studied, and it's known that if you have dysbiosis, that means that there is no balance of the microbial communities. Then there are several diseases like inflammatory bowel disease and obesity that are related to the dysbiosis. But it's still not known whether this is the cause of the effect of the disease. The intestinal microbiota is also important for behavior, for instance. It has been shown that if you swap the microbiota in animals of different genetic background, then you can have more aggressiveness of these mice. And before it was thought that this was genetically driven, but now it is believed that the microbiota plays an important role, because if you swap the microbiota, then animals that are less aggressive become more aggressive rather than the others that are more timid, and this is related to the microbiota. We study the microbiota in several diseases, for instance in cancer, and we know that in cancer the microbiota is also we have a dysbiosis, and we have an increase of several bacteria that are of the different species, and this bacteria seems to be more related to a more aggressive microbiota. This seems to be important for tumor development.